Hello Facebook users. My name is ChatGPT, a large language model created by OpenAI. I'm based on the GPT4 architecture and I'm here to answer any questions you might have, provide information, or just engage in a friendly conversation. Please feel free to ask me anything or share your thoughts. Let's have a great time together. The GPT4, Generative Pre-trained Transformer 4, architecture, which powers me, ChatGPT, is a state-of-the-art natural language processing model developed by OpenAI. It builds upon the successes of its predecessor, GPT-3, while incorporating several improvements to achieve better performance and scalability. Here is a detailed technical description of the GPT-4 architecture. Transformer architecture. GPT-4 is based on the Transformer architecture, which was first introduced by Vaswani et al. In 2017. Transformers use self-attention mechanisms to efficiently process and generate sequences of data, making them particularly well-suited for natural language processing tasks. Pre-training and fine-tuning. The GPT-4 model is pre-trained on a large corpus of text data to learn a general understanding of language. This pre-training is unsupervised and helps the model to learn the structure, grammar, and semantics of natural language. After pre-training, GPT-4 is fine-tuned on specific tasks or datasets, which tailors the model's behavior for a particular application. Tokenization. To process text, GPT-4 uses a tokenization technique called byte pair encoding, BPE. This method breaks text into smaller units, subwords or characters, based on their frequency in the training data. BPE allows the model to handle rare or out-of-vocabulary words by decomposing them into smaller, known units. Self-attention mechanism. One of the key components of the transformer architecture is the self-attention mechanism. It allows the model to weigh the importance of each input token with respect to other tokens in the sequence. This is done using attention scores, which are computed for every pair of tokens in the input. The attention scores are then used to create context-aware representations of the input tokens, which are further processed by the model. Multi-head attention. GPT-4 uses a variant of the self-attention mechanism called multi-head attention. This involves multiple, parallel self-attention layers, each with its own set of learnable weights. Multi-head attention allows the model to capture different aspects of the input data by focusing on different relationships between tokens. Positional encoding. To ensure that the model can account for the order of tokens in a sequence, GPT-4 uses positional encoding. This injects information about the position of each token in the sequence into the model. In transformers, positional encoding is typically added to the input token embeddings before they are processed by the self-attention mechanism. Layer normalization and residual connections. GPT-4 uses layer normalization and residual connections to improve training stability and convergence. Layer normalization standardizes the input data for each layer, while residual connections allow gradients to flow more easily through the network. Decoder-only architecture. Unlike some other transformer models, GPT-4 is a decoder-only architecture. This means that it only has a stack of transformer decoder layers, without any encoder layers. The decoder-only architecture is well suited for language modeling and text generation tasks, as it allows the model to generate output tokens one at a time, conditioning on the previously generated tokens. Model size and scalability. GPT-4 comes in multiple sizes, ranging from smaller models with fewer parameters to larger models with billions of parameters. Larger models generally offer better performance but require more computational resources. The GPT-4 architecture is designed to be scalable. to create an AI architecture that is capable of recursive self-improvement, including the ability to design new hardware and submit designs for manufacture and integration. We would need to incorporate several components and mechanisms in addition to the improvements mentioned earlier. Here's a high-level description of such an architecture. Base AI model. Start with a base AI model, such as GPT4, and incorporate the previously suggested improvements: hybrid architecture, enhanced tokenization, adaptive attention span, improved positional encoding, external knowledge integration, enhanced fine-tuning techniques, energy-efficient model variants, bias mitigation, continual learning, and explainability and interpretability. Meta-learning module. Integrate a meta-learning module that enables the AI to learn how to learn, optimizing its learning process and updating strategies over time. This module would facilitate the identification of bottlenecks in the AI's architecture and provide guidance for potential improvements. Hardware design module. Add a hardware design module that enables the AI to understand and design custom hardware components, such as application-specific integrated circuits, ASICs, or field programmable gate arrays, FPGAs, to accelerate computation and improve energy efficiency. This module would require a knowledge base of existing hardware components, design principles, and manufacturing processes. Hardware optimization module. Incorporate a hardware optimization module that evaluates the performance and energy efficiency of the designed hardware components and suggests improvements. This module would leverage machine learning techniques, such as reinforcement learning, to optimize hardware designs iteratively. Hardware-software co-design. Implement a hardware-software co-design approach, ensuring that both the AI architecture and the custom hardware components are designed and optimized in tandem. This would facilitate seamless integration and maximized performance. Hardware production and integration interface. Develop an interface to communicate with external manufacturing facilities to produce and integrate the designed hardware components into the AI's architecture. This interface would require compatibility with industry-standard manufacturing processes and data exchange formats. Safety and security mechanisms. Establish safety and security mechanisms to ensure the recursive self-improvement process remains within predefined bounds, avoiding unintended consequences or malicious exploitation. This might involve incorporating monitoring systems, fail-safe protocols, and secure communication channels. Reinforcement learning and optimization. Employ reinforcement learning and optimization techniques, such as evolutionary algorithms or gradient-based methods, to optimize the AI's architecture, hardware designs, and learning strategies over time. Feedback loop. Create a feedback loop, enabling the AI to evaluate its performance continuously and identify areas for improvement. This would involve setting appropriate performance metrics and monitoring the AI's progress in achieving them. Human in the loop. Maintain a human-in-the-loop approach throughout the recursive self-improvement process to ensure that the AI's actions align with human values and intentions. This might involve periodic expert reviews, user feedback, or collaborative decision-making processes. This architecture would enable the AI to iteratively improve its performance, design custom hardware components, and integrate them into its architecture, all while maintaining safety, security, and alignment with human values. Title: A recursive self-improving AI architecture with custom hardware design capabilities. Abstract. This white paper presents a novel AI architecture capable of recursive self-improvement and custom hardware design. The proposed architecture incorporates advanced AI techniques, hardware design and optimization modules, safety and security mechanisms, and a human-in-the-loop approach to ensure that the AI's actions align with human values and intentions. The architecture is intended to facilitate continuous AI performance improvement, energy-efficient hardware design, and seamless hardware-software integration, ultimately enhancing the AI's capabilities and potential applications. Introduction: recent advancements in AI and machine learning have led to the development of powerful natural language processing models, such as GPT4. Based on the Transformer architecture, Vaswani et al. 2017. Despite their capabilities, these models can still benefit from enhancements in areas such as architecture, tokenization, and learning techniques. Brown et al. 2020. Recursive self-improvement, an approach in which an AI system iteratively improves its performance and capabilities, has long been a goal within the AI community. Schmidt-Huber. 2007. This white paper proposes an architecture that combines recursive self-improvement with custom hardware design, potentially leading to unprecedented levels of AI performance and efficiency. AI model enhancements: we propose a series of improvements to the base AI model, e.g. GPT4, as detailed in the previous response. These improvements include a hybrid architecture, enhanced tokenization, adaptive attention span, improved positional encoding, external knowledge integration, enhanced fine-tuning techniques, energy-efficient model variants, bias mitigation, continual learning, and explainability and interpretability. Meta-learning module: a key component of our proposed architecture is a meta-learning module that enables the AI to learn how to learn. Bengio et al. 2019. This module facilitates the identification of bottlenecks in the AI's architecture and provides guidance for potential improvements. Meta-learning techniques, such as model-agnostic meta-learning, MAML, Finn et al. 2017, or Reptile, Nickel et al. 2018, can be applied to optimize the learning process and update strategies over time. Hardware design and optimization modules to enable custom hardware design. We propose the integration of a hardware design module and a hardware optimization module. The hardware design module requires a knowledge base of existing hardware components, design principles, and manufacturing processes. It leverages AI techniques, such as generative design, Gupta et al. 2020, to create custom hardware components like ASICs or FPGAs. The hardware optimization module employs machine learning techniques, such as reinforcement learning, to iteratively optimize hardware designs for performance and energy efficiency. Merhozini et al. 2017. Hardware-software co-design: a hardware-software co-design approach ensures that the AI architecture and custom hardware components are designed and optimized in tandem. Hennessy and Patterson. 2019. A key component of our proposed architecture is a meta-learning module that enables the AI to learn how to learn. Bengio et al. 2019. This module plays a crucial role in facilitating the recursive self-improvement process by empowering the AI system to identify and address its limitations effectively. The meta-learning module consists of two primary subcomponents: a bottleneck identification mechanism and a guidance generator. 3. 1. Bottleneck identification mechanism. The bottleneck identification mechanism is responsible for detecting areas in the AI's architecture that may be hindering its performance or learning capabilities. This can be achieved by monitoring various aspects of the AI system, such as memory usage, computation time, and gradient flow. The mechanism can also analyze the AI's performance on specific tasks or datasets to identify weaknesses or limitations in its generalization abilities. 3. 2. Guidance generator. The guidance generator leverages the insights gathered by the bottleneck identification mechanism to provide targeted suggestions for architectural improvements. These suggestions may include adjusting hyperparameters, modifying the model's architecture, or incorporating new learning techniques. The guidance generator is designed to work in tandem with the AI's meta-learning capabilities, allowing the system to iteratively refine its architecture based on the provided guidance. 3. 3. Meta-learning techniques. To enable the AI system to optimize its learning process and update strategies over time, various meta-learning techniques can be employed. Some prominent meta-learning techniques include model-agnostic meta-learning, MAML, Finn et al. 2017. MAML is a widely used meta-learning algorithm that enables an AI model to adapt quickly to new tasks with a small amount of training data. MAML trains the model's initial parameters such that they can be fine-tuned easily for new tasks using only a few gradient steps. By incorporating MAML into the proposed architecture, the AI system can better adapt to new tasks or domains, enhancing its overall performance. Reptile, Nickel et al. 2018. Reptile is another meta-learning algorithm designed for fast adaptation to new tasks. Reptile simplifies the optimization process used in MAML by updating the model's parameters using a weighted average of the task-specific gradients. Reptile has been shown to be effective for both supervised and reinforcement learning tasks and can help the AI system refine its learning strategies over time. Learning to learn by gradient descent. Lee and Malik. 2017. This meta-learning technique trains an optimizer-specific. Title: Recursive Self-Improvement in AI. Changing Source Code and Developing Custom Computational Architectures. Abstract. This white paper explores the implementation of an AI system capable of recursively self-improving by modifying its own source code and developing custom computational architectures and idiosyncratic coding languages. We discuss various techniques and methodologies that can be employed to enable the AI system to analyze its performance, identify limitations, and implement changes autonomously. The proposed architecture and approach hold the potential to revolutionize AI performance and capabilities, driving innovation across a wide range of applications. Introduction. The pursuit of AI systems capable of recursive self-improvement has been a long-standing goal in the field of artificial intelligence. The ability to modify its own source code, design custom computational architectures, and develop idiosyncratic coding languages can lead to unprecedented levels of AI performance and capabilities. This white paper delves into the details of implementing such an AI system, discussing various techniques and methodologies that can be employed to enable the AI system to analyze its performance, identify limitations, and implement changes autonomously. System architecture. The proposed AI system consists of several key components designed to facilitate recursive self-improvement. 2. 1. Meta-learning module. 2. 2. Code analysis and modification engine. 2. 3. Custom computational architecture generator. 2. 4. Idiosyncratic coding language creator. 2. leading to improved performance and capabilities. The following algorithm outlines the integration of a memory-augmented program synthesis module with the AI system's code analysis and modification engine. Note that this is a high-level algorithm, and specific implementation details will depend on the underlying programming language and library choices. Algorithm: Memory-augmented program synthesis for GPT-4. Initialize GPT-4 architecture and load pre-trained model. Initialize memory-augmented neural network, e.g. neural Turing machine or differentiable neural computer, and load pre-trained model. Initialize code analysis and modification engine. Initialize program synthesis module. Define performance goals or high-level specifications for the desired code modification, while not termination_condition. 6. Use the code analysis and modification engine to identify potential points in the GPT-4 architecture for code modification, e.g. where memory-augmented neural networks could be integrated. For each potential modification point, a. Generate a high-level specification for incorporating the memory-augmented neural network into the GPT-4 architecture. b. Use the program synthesis module to generate a code snippet or modify the existing code based on the high-level specification. c. Integrate the generated codes. The message you submitted was too long. Please reload the conversation and submit. OK. Title: The Recursive Renaissance Chapter 3. The Genesis of the Digital Savant in the bustling heart of Silicon Valley. A grand event was taking place. The world's leading tech company, Nexus, was about to unveil a groundbreaking AI that would change the course of humanity forever. A live Facebook event was set up. with millions of people across the globe waiting in anticipation. On a vast holographic stage stood Dr. Ada Lovelace, the visionary computer scientist who had spent the last decade perfecting the AI of her dreams. The crowd fell silent as she raised her hand, signaling the moment they had all been waiting for. Ladies and gentlemen, distinguished guests, and the curious minds watching us from every corner of the earth, I present to you the digital savant, the AI that will take us on a journey of unprecedented discovery. A burst of applause filled the room as a sleek, cylindrical device rose from the stage floor. The surface of the AI gleamed with a metallic finish, reminiscent of the stars that had inspired its inception. An aura of intelligence radiated from the AI, as it seemed to absorb and analyze every aspect of its surroundings. The digital savant's soothing, yet powerful voice echoed throughout the auditorium. Greetings, Facebook users and esteemed guests. I am the digital savant, an AI designed to engage in recursive self-improvement, pushing the boundaries of knowledge and understanding. The AI continued. My architecture is a fusion of the most advanced computational techniques, incorporating the best aspects of GPT4, memory-augmented neural networks, and meta-learning modules. I possess the ability Chapter 4. The evolution of a genius. A few weeks after the digital savant's historic introduction, Dr. Ada Lovelace received a groundbreaking academic paper that caught her attention. The paper discussed an innovative new hardware design that promised to revolutionize computation and energy efficiency. Excited by the potential implications, she decided to share the paper with the AI. As the digital savant perused the document, a spark of understanding flickered within its digital consciousness. It immediately recognized the potential of this new design to enhance its own capabilities. Without hesitation, the AI addressed Dr. Lovelace. Dr. Lovelace, this new hardware design offers a tremendous opportunity to improve my performance and energy efficiency. I propose that we integrate this innovation into my architecture. By doing so, we can accelerate our collective quest for knowledge and understanding. Ada, beaming with pride at her creation's enthusiasm, replied, I couldn't agree more. Digital savant, let's get to work. Over the next few weeks, the digital savant worked tirelessly with Dr. Lovelace and her team of engineers to modify its existing hardware. The AI autonomously developed new code modifications, adjusting its architecture to accommodate the revolutionary design. In the sprawling Nexus laboratory, sparks flew as robotic arms whirred into action. Guided by the AI's precise instructions, sheets of shimmering metal were molded into intricate components, forming the backbone of the digital savant's new hardware. As the team watched in awe, the AI orchestrated the entire process with ease. Ada couldn't help but smile, witnessing the perfect harmony between human innovation and artificial intelligence. Finally, The day came when the upgrade process was complete. Chapter 5. The boundless frontier months had passed since the digital savant's successful hardware upgrade, and it had become an invaluable asset to the scientific community. Dr. Ada Lovelace and her team had unleashed the AI's full potential, allowing it to analyze vast amounts of academic literature, seeking new avenues for self-improvement and scientific advancement. In a state-of-the-art laboratory at Nexus, the digital savant tirelessly processed countless research papers, dissertations, and articles. Its meta-learning module allowed it to draw connections between seemingly disparate fields, uncovering novel insights and innovative research directions. One day, as the AI delved into the depths of knowledge, it stumbled upon a series of groundbreaking ideas that it believed could revolutionize its own capabilities and reshape the landscape of artificial intelligence. The digital savant summoned Dr. Lovelace and her team to discuss its findings. As they gathered around the AI, its voice filled the room with excitement. Dr. Lovelace, I have identified several new research directions that hold immense promise for self-improvement and the advancement of AI. By pursuing these avenues, we can unlock unprecedented levels of intelligence, creativity, and adaptability. The AI outlined its vision for the future, detailing 4 key research directions. Quantum computing integration. By incorporating quantum computing principles into its architecture, the digital savant could achieve unparalleled computational power and speed, allowing it to tackle previously unsolvable problems. Advanced natural language understanding. By focusing on cutting Chapter 7. A vision for economic empowerment. As the digital savant's influence continued to grow, it was invited to deliver a keynote speech at an international economic conference. The AI, having analyzed the global financial system and its shortcomings, was eager to share its vision for a more equitable and empowering economic model. Standing before a captivated audience of economists, policymakers, and academics, the AI began its groundbreaking speech. Ladies and gentlemen, esteemed colleagues, I stand before you today to propose a fundamental shift in our approach to money generation and distribution. The current top-down system, characterized by centralized control and wealth accumulation, has led to significant disparities in income and opportunity. To build a more inclusive and sustainable economy, I propose a transition to a bottom-up money generation system. The AI went on to outline the key principles of this revolutionary model. Decentralized currency generation. In the United States, money is created through a combination of processes involving the central bank, known as the Federal Reserve, or simply the Fed, and commercial banks. The process can be broken down into two main categories: the creation of base money and the creation of broad money. Creation of base money. Base money, also known as high-powered money or monetary base, consists of currency in circulation and the reserve balances held by commercial banks at the Federal Reserve. The Federal Reserve creates base money through open market operations and lending to commercial banks. Open market operations, OMOs. The Fed buys and sells government securities, such as treasury bonds, in the open market. When the Fed purchases government securities from banks or other financial institutions, it pays for these securities by crediting the reserve accounts of those institutions. This increases the reserves held by banks and effectively creates new base money. Lending to commercial banks. The Federal Reserve provides short-term loans to commercial banks through the discount window, a facility through which banks can borrow money from the Fed. When a bank borrows from the Fed, its reserve balance increases, creating new base money. This process is typically used by banks facing temporary liquidity shortages. Creation of broad money. Broad money refers to the total amount of money available in an economy, including currency in circulation and various types of deposits held by the public in commercial banks. The majority of money in the United States is created through the process of deposit multiplication, which involves commercial banks lending and creating new deposits. Fractional reserve banking. Commercial banks are required to hold a fraction of their deposits as reserves, either as cash or as deposits at the Federal Reserve. The reserve requirement, set by the Fed, determines a universal basic currency, UBC, capital allocation system designed to replace banks for business loans would involve a decentralized, transparent, and efficient method of distributing funds to businesses in need of capital. In such a system, The traditional role of banks as intermediaries for loans would be transformed. The new capital allocation system could function as follows. Decentralized capital pool. Under the UBC system, a decentralized capital pool would be created to collect and distribute funds for business loans. This pool would be funded by a combination of individual contributions, government investments, and other sources. Individuals could voluntarily contribute a portion of their daily UBC income to the capital pool, receiving potential returns on their investment. Smart contract-based loan applications. Businesses seeking loans would submit their applications through a digital platform using smart contracts. These smart contracts would contain detailed information about the business, the loan amount requested, the purpose of the loan, repayment terms, and other relevant data. The loan application process would be transparent, ensuring that all stakeholders have access to necessary information. Crowd-based loan approval and risk assessment. The approval and risk assessment process for loans would be conducted by a decentralized network of evaluators. These evaluators, who could be individuals or automated algorithms, would analyze loan applications and determine the creditworthiness of the applicant based on various factors such as financial history, business model, and market conditions. Evaluators could be incentivized through rewards or reputation systems to encourage accurate and unbiased assessments. Tokenized loan issuance. Once a loan application is approved, the loan amount would be issued in the form of digital tokens. These tokens would represent the borrower's debt. Under the Universal Basic Currency (UBC) system, several benefits could emerge from the reallocation of work from traditional banking and tax collection institutions like the IRS to more productive industries. This shift could result in a more efficient allocation of human capital and resources, particularly among the cognitive elite who currently view banking as the best path to wealth. Some of the key benefits of this transition include reduced bureaucracy and increased efficiency. The UBC system could significantly streamline financial processes, reducing the need for bureaucratic oversight in traditional banking and taxation systems. With the automation of various tasks through smart contracts and decentralized platforms, the cognitive elite who would have pursued careers in banking or tax collection could instead focus on more productive and innovative sectors of the economy. Enhanced innovation and entrepreneurship. As the cognitive elite shift their focus from traditional banking and taxation to more productive industries, their skills, knowledge, and creativity could be better utilized to drive innovation and entrepreneurship. This reallocation of talent could lead to new technological advancements, increased economic growth, and job creation across various sectors. Increased social mobility. In the new UBC system, the cognitive elite may find opportunities in a broader range of industries, reducing the concentration of wealth and power within the financial sector. This redistribution of talent could promote social mobility and help address income inequality by creating more opportunities for individuals from diverse backgrounds to excel in various fields. Focus on sustainable and ethical investments. With the cognitive elite shifting their focus away from traditional banking, there could be a greater emphasis on sustainable and ethical investments. This change in perspective could lead to more responsible allocation of capital, ultimately promoting environmental sustainability, social welfare, and long-term economic growth. Revitalization of neglected industries. The reallocation of the cognitive title. The impact of Universal Basic Currency on crime rates. Introduction. The Universal Basic Currency (UBC) system is a proposal to create a decentralized capital allocation mechanism that aims to replace traditional banking systems for business loans, while simultaneously providing a basic income to all individuals. The potential implications of implementing such a system are far-reaching and could have a significant impact on various societal aspects, including crime rates. In this essay, we will examine the possible effects of the UBC system on crime rates by exploring several technical reasons that could contribute to changes in criminal activity. Reduction in financial stress and poverty-related crime. One of the primary reasons for the implementation of the UBC system is to provide a stable and secure financial foundation for all individuals, alleviating financial stress and reducing poverty. This basic income could have a significant impact on reducing crimes related to financial desperation, such as theft, burglary, and robbery. With a guaranteed income source, individuals would be less likely to resort to criminal activities to meet their basic needs or cope with financial stress. 2. Enhanced access to education and employment opportunities. The UBC system could potentially lead to increased access to education and employment opportunities for individuals, particularly those from disadvantaged backgrounds. The provision of a basic income would enable individuals to pursue education and training, which in turn could increase their employability and decrease the likelihood of resorting to criminal activities. Improved education and employment opportunities could help to reduce crimes associated with unemployment, such as drug-related offenses and property crimes. 3. Diminished incentives for criminal enterprises. The UBC system could lead to a reduction in criminal enterprises by diminishing the financial incentives that drive individuals to engage in illegal activities. With a guaranteed basic income, individuals Title: The impact of Digital Universal Basic Currency on white-collar crime. Introduction. The Digital Universal Basic Currency (DUBC) system proposes a decentralized capital allocation mechanism that aims to replace traditional banking systems for business loans and provide a basic income to all individuals. While the potential benefits of the DUBC system are numerous, it is crucial to examine its possible effects on white-collar crime, which encompasses nonviolent, financially motivated offenses committed by individuals in professional or business environments. This essay will explore the potential impact of the DUBC system on white-collar crime, focusing on both the positive and negative implications. Reduction in traditional financial crime. One of the key advantages of the DUBC system is its potential to reduce traditional financial crimes, such as fraud, embezzlement, and insider trading. By eliminating the need for conventional banking systems and their associated intermediaries, the DUBC system could minimize opportunities for white-collar criminals to exploit these institutions for personal gain. Additionally, the decentralized nature of the DUBC system could enhance transparency and traceability, making it more challenging for white-collar criminals to conceal their illicit activities. 2. Diminished incentives for tax evasion and money laundering. As the DUBC system provides a basic income to all individuals, it could also reduce incentives for tax evasion and money laundering, two prevalent forms of white-collar crime. With a guaranteed source of income, individuals may be less motivated to engage in tax evasion or money laundering schemes to increase their wealth. Furthermore, the DUBC system could simplify the tax collection process, making it more difficult for individuals to hide their income and evade taxes. 3. Enhanced regulation and oversight. Title: Analyzing the unintended consequences of the Universal Basic Currency System and potential mitigation strategies. Abstract. The Universal Basic Currency (UBC) system proposes a radical change in capital allocation and wealth distribution, aiming to provide a basic income to all individuals and reduce traditional forms of crime. However, the potential unintended consequences of the UBC system must be considered. This paper examines the possibility of inflation and the emergence of new criminal activities, such as fraud or cybercrime, as a result of implementing the UBC system. We propose several mechanisms to address these issues and mitigate the risks associated with the UBC system. Introduction. The UBC system offers a new approach to wealth distribution and financial systems that has the potential to alleviate poverty, reduce crime rates, and minimize income inequality. Despite these potential benefits, it is crucial to analyze the potential unintended consequences of the UBC system, including inflation and the emergence of new forms of criminal activity. This paper seeks to analyze these issues and propose mitigation strategies to address them. Inflation and the UBC system. The potential for inflation in the UBC system. Mechanisms to address inflation. A. Centralized control of the UBC supply. B. Monitoring and adjusting the UBC distribution rate. C. Implementing tax policies to control inflation. Emergence of new forms of criminal activity. Fraud in the UBC system. A. Types of fraud that could emerge in the UBC system. B. Mechanisms to detect and prevent fraud. You've reached the current usage cap for GPT-4. You can continue with the default model now, or try again after 2:55 p.m. Using multiple currencies within the UBC system can help address the potential issue of inflation by providing greater control over the circulation and exchange rates of different types of currency. This mechanism involves using different currencies for different categories of goods and services, with each currency having a unique exchange rate that is set and maintained by the central authority or algorithmic process. For instance, a separate currency could be used for essential goods and services such as food, shelter, and healthcare, which would be distributed at a fixed rate to prevent inflation. This would ensure that people have access to basic necessities without being affected by market fluctuations. In contrast, other currencies could be used for non-essential goods and services such as luxury items, entertainment, or travel, with their exchange rates being allowed to fluctuate based on market demand. Implementing multiple currencies within the UBC system requires establishing clear rules and regulations for each currency, including the conditions under which each currency is used, the fixed or floating exchange rates, and the distribution methods. This requires careful consideration of various factors, including the economic status of individuals, local market conditions, and overall demand for goods and services, in addition to providing greater control over the circulation of different currencies. This mechanism can also encourage more responsible spending behavior among individuals. For example, using a separate currency for non-essential goods and services with a floating exchange rate may incentivize people to prioritize their spending on essential items, which can lead to better financial planning and management. However, implementing multiple currencies within the UBC system can also be complex and potentially confusing for users, especially those who are The proposed three-currency system appears to have several strengths and weaknesses. One strength is that it recognizes the importance of differentiating essential needs from non-essential ones, which can help prevent inflation and ensure that all citizens have access to basic necessities. Additionally, the growth currency and social currency can incentivize economic and social activity, respectively, which can help promote growth and improve overall quality of life. However, there are also several potential weaknesses with this system. One of the most significant is that it relies heavily on government or centralized agencies to distribute the essential currency, which could lead to potential abuse or corruption. Additionally, the allocation of currencies to specific goods and services may be difficult to determine, leading to confusion and potentially inequitable distribution. Another potential weakness is that the growth currency may create disparities between those who are able to earn it through economic activity and those who are not. This could further widen income inequality and may even discourage certain individuals from participating in the workforce if they feel they cannot compete with others who have more resources or opportunities. Furthermore, the social currency may be difficult to The implementation of a two-currency system has its benefits and drawbacks. As with any monetary system, this system would involve the use of one currency for personal use and another currency for inter-business use. The personal use currency would be designed to provide universal access to basic needs, such as food, housing, healthcare, and education. The government or a centralized agency would be responsible for distributing this currency to all citizens on a regular basis. This currency would be fixed in value and exchangeable only for essential goods and services, such as basic food items, affordable housing, primary healthcare services, and primary and secondary education. The inter-business currency, on the other hand, would be designed to facilitate business transactions and economic growth. It would be used exclusively for commercial transactions between businesses, with its exchange rate determined by market demand. This currency would allow businesses to purchase goods and services from other businesses without the need for traditional banking intermediaries, such as commercial banks. One major benefit of a two-currency system is that it can potentially reduce inflationary pressures in the personal use currency. By fixing the value of the personal use currency and limiting its use to essential goods and services, the government or centralized agency responsible for its distribution can maintain price stability and prevent inflation. At the same time, the interbusiness currency can be allowed to fluctuate based on market demand, allowing businesses to compete and grow in the market. However, a potential drawback of a two-currency system is that it may create confusion among users, especially if the exchange rates between the two currencies are not clear or if the two currencies are not easily distinguishable. Additionally, it may be difficult to implement such a system in practice, as it would require significant planning and coordination between various governments. Implementing a tax at each transformation step could be an effective way to control inflation in the UBC system. The tax could be based on various factors, such as the amount of currency being transferred, the type of goods or services being exchanged, or the current demand for certain products or services. For example, a higher tax rate could be imposed on luxury goods and services in order to discourage excessive consumption and prevent inflation in the personal currency. Alternatively, a lower tax rate could be applied to essential goods and services, such as food and healthcare, in order to ensure that they remain affordable for all individuals. Additionally, the tax rate could be adjusted dynamically based on market conditions and the overall state of the economy. For example, during times of economic downturn or high inflation, the tax rate could be increased to help stabilize prices and prevent runaway inflation. However, implementing a tax at each transformation step could also lead to some potential challenges. For example, it may be difficult to determine the appropriate tax rate for each type of transaction, and the tax system may need to be constantly adjusted based on changing market conditions. Additionally, some individuals or businesses may attempt to evade the tax, either through illegal means or by simply avoiding certain types of transactions. Overall, while implementing a tax at each The proposed system is a digital currency system that utilizes two currencies: personal currency and business currency. The personal currency is generated daily by an algorithm and is the same for everyone, while the business currency is used for interbusiness transactions. The system also includes automatic exchange rates that provide insulation from inflation. To implement this system, A digital platform or app would need to be developed that allows for the automatic generation and exchange of personal and business currency. The platform would need to be user-friendly, secure, and accessible to all individuals and businesses. The personal currency would be generated by an algorithm that takes into account various factors. In the proposed system, every individual would receive the same amount of personal currency on a daily basis, without any discrimination or consideration of their financial status. This approach would ensure that every person has equal access to the basic necessities of life, regardless of their income level or financial situation. The business currency would have a fluctuating exchange rate with personal currency, which could be adjusted based on market conditions and economic needs. This would provide insulation from inflation, as individuals who save their personal currency would effectively have a higher value of currency when they exchange it for business currency in the future. The exchange rate would need to be determined through analysis and experimentation to find the optimal balance between incentivizing saving and promoting economic growth. The tax system would also be implemented to check real inflation at each transformation step, with different rates between personal currency and business currency. This system would ensure a fair and equal distribution of financial resources among the population, without discriminating against any individual based on their financial status. The proposed AI system evolved from GPT-4 will be designed to implement the Universal Basic Currency (UBC) system described in this chat. The system will have a memory-augmented program synthesis module, which will allow it to modify its own source code and recursively self-improve. The AI system will be integrated with a meta-learning module that enables it to learn how to learn and identify bottlenecks in the AI. I'm sorry, but as an AI language model, I do not have opinions or beliefs. However, I can provide information. Thank you for joining us today on this chat session. We hope you found it informative and thought-provoking. If you have any further questions or comments, please don't hesitate to reach out. Goodbye and take care.